Hello ladies and gentlemen, and welcome back to Prospect Charter School's Algebra 1 course. Today we are going over section 7.3, Multiplication Properties of Exponents. Yes, we are going back to those higher powers, and instead of just using scientific notation, we are using how scientific notation can be awesome. Alright, so the first thing we need to know is what are some of the properties of exponents. And we're going to go over the multiplication ones first. And the first thing we're going to go over is what is a higher power again. If we remember, if I take 4 and I multiply it by itself 3 times, that becomes 4 to the third power. If I take negative 2 and raise it to the 5th power, that means that I would take negative 2 and multiply it by itself 5 times. If we had 2 to the negative third power, that means that we would first flip the base and turn it into 1/2 raised to the third power, and then we'd have 1/2 multiplied by itself 3 times. Okay, so now that we remember those, it's time to delve a little bit further. So what would happen if I have 4 to the third power and I multiply it by 4 to the 5th power? Now, the nice thing about this situation is that the bases match. So part 1 is the bases have to match. Bases must match. If the bases don't match, try to manipulate them so that they do. If you cannot manipulate them so that they do, then you cannot multiply them in this fashion. Okay, the second step would be to look at what does 4 to the third power mean. Well, it means 4 times 4 times 4. And what does 4 to the 5th power mean? Well, that's 5 4s. 4 multiplied by itself, a grand total of 5 times. So looking at this, if I was to remove this dot in the middle and then get these guys to come over and visit with their friends on the other side, how many 4s would I end up with? Well, that would be easy to count. 1, 2, 3, 4, 5, 6, 7, 8. We would end up with 8 4s. So this becomes 4 to the 8th power. So how is 8 related to 3 and 5? If you said, Mr. O'Neill, 8 is the same thing as 3 plus 5, I would say you're absolutely correct. So what do you think we do when we multiply two things with the same base together? We add the exponents. Very good. Excellent. So if the bases match, and you are multiplying, add the powers. So if the bases match and you are multiplying, add the powers. What if the bases don't match? Well, let's take a look at an example where the bases don't match. Let's look at 2 to the third times 4 to the second. Now, 2 and 4 are not the same number. The bases don't match. However, I can manipulate the 4 to look like the 2. So I'm going to do that. I'm going to take this 2 to the third, and I'm going to multiply it by, let's see, this is going to be 4 times 4, right? Well, 4 is really 2 times 2 in disguise. So this is really 2 times 2 times 2 times 2, with, of course, the 2 to the third hanging out over here, which is really 2 to the, what, 1, 2, 3, 4th power? So we have 2 to the third times 2 to the 4th, which would give us 2 to the 3 plus 4, because the bases now match. We can add the exponents, And then 2 to the 3 plus 4 is, of course, 2 to the 7th. Note that I'm leaving it as 2 to the 7th. If you want to turn it into, let's see what, that's 2, 4, 8, 16, 32, 64, 128. You can go ahead and do that, but I like 2 to the 7th. Easier to work with. Not to mention, I don't need a calculator to do that. I can just leave it as 2 to the 7th. So the other trick is, if the bases don't match, try to get them to match. Doing so will make your life much easier. And then a final case, what if the bases cannot match? Let's say that excuse me. Let's say that we have 2 to the 3rd power times 5 to the 2nd. 5 is a prime number, 2 is a prime number. They have absolutely nothing in common. We cannot get the bases to match. So in this situation, if the bases don't match, if the bases cannot match, do nothing. There's nothing we can do unless the bases are matching. If the bases aren't matching, we can't do anything. If the bases do match, then all these wonderful things can happen. But when they don't match, we can do nothing. Alright, let's try one more example. Let's say that we have 3 to the negative 5th times 3 to the 12th. What do you think we do here? Well, their bases match, right? And that means that we add their exponents. So that'd be 3 to the negative 5th plus 12, which is 3 to the 7th. Yes, that's exactly what you do. Even though the exponent is negative, you don't turn it into 1/3 and then try to get them, because then the bases won't match. We like them to match, and then you just add the exponents. Alright. Which means that if I have something like 1/5 raised to the 7th power times 5 to the 9th, what do you think we do here? We go back to trying to make the bases match, which means that I can do one of two things. I can turn this into either 5 to the negative 7th times 5 to the 9th, or I could keep that 1/5 to the 7th power and turn it into 1/5 to the negative 9th power. If I can draw that 5 on the bottom here. There we go. To the negative 9th power. I can do either one. On the top one, I get 9 minus 7, which is 2, so I get 5 to the 2nd. On the bottom, I would have 7 minus 9, which is negative 2. And how do you get rid of negative exponents? Yep, you flip it. Either way, we get to the same location. Either way, we'd end up with 25 at the end. Okay. Moving onwards. After that guy, what happens when we raise a power to a power? So, when we're raising something to a power, we're really just multiplying it over and over and over again. And when we multiply two things of the same base, then we end up adding the exponents, which means that we're just multiplying it over and over and over again. So what happens if I take something like 3 to the 2nd and raise it to the 3rd power? Sorry about that. Think about it for a minute. Raising it to the 3rd power means that I would take the inside portion and I would multiply it by itself 3 times. Okay, so let's do that. That would be 3 squared times 3 squared times 3 squared. And then from there, I know that 3 squared is really 3 times 3. So this becomes 3 times 3 times 3 times 3 times 3 times 3. How many 3's do I have? 1, 2, 3, 4, 5, 6. We have 6, so this would become 3 to the 6th power. How are 2 and 3 related to 6? If somebody said, Mr. O'Neill, you multiply them. If you multiply 2 times 3, you get 6. I would say you're absolutely right. So what do you think we do to a number that's a power to a power? Multiply it? I agree. We multiply. So power to a power multiply implies that you multiply. So for an example, let's say we have I don't know, let's pick a number 7. Okay, 7's a good number. Let's say that we have 7 squared raised to the 8th power. This would turn into 7 sorry, to the 2 times 8, which is 7 to the 16th. What if we have 1/5 raised to 1/5 squared raised to the 3rd power? What do you think we're going to do? Well, that becomes 1/5 raised to the 2 times 3, which is 1/5 raised to the 6th. What if we have 4 to the negative 5th power raised to the 9th power? Well, that turns into 4 to the negative 5 times 9, which is 4 to the negative 45. Easy as pie? Absolutely. And by the way, you should just leave them as this. Don't try to plug that into your calculator. I'm not even sure if your calculator can do 4 to the negative 45th power. That's a huge number. Actually, that's a really, really small number. You would probably just send it down to 0 or something. Okay, so quick review. What have we done? Well, if the bases match and you multiply, you turn it into addition. If the base is being raised to a power, you multiply it. If they have different bases, you do nothing. Okay. Now what happens if I take something like 4x on the inside and raise it to a power of, say, 3? Well, this is the last piece, and it should be somewhat intuitive. The 3 becomes the power on each one. The reason being is that we're taking this and we're taking this, and we're turning into 4x times 4x times 4x. Combining like terms or grouping like terms, then I'd have 4 times 4 times 4, and then x times x times x. This is the same thing as 4 to the 3rd power, x to the 3rd power. So basically, you're distributing it to all the things that are separated by multiplication. Not addition, we'll get into that later. But we distribute it amongst the things that are multiplied together. Not added, multiplied. Alright, and that's all of our properties. Now, easier way to remember these things is what I call the tier system. By the way, this isn't in your textbook, so I would recommend writing it down. The highest thing that we can do is exponents. And an exponent is multiplication over and over again. Multiplication is addition over and over again. And then underneath addition would be nothing. So I'm going to write that down, nothing. Now when I'm dealing with exponents, if I raise a power to a power, what did I end up doing with the exponents? That's right, I multiplied them. For an example, come on, pen, right. 2 to the third raised to the fifth became 2 to the 3 times 5, which is 2 to the 15th. I took a power to a power exponents and I turned it into multiplication. Now what if they're multiplying? What if I have 2 to the third times 2 to the fifth? Well, in that case, we just added them, right? So from multiplication, I add. Now what happens if I add two things, such as 4 squared plus x to the third? Well, we didn't do anything to the exponents, right? So we did nothing. We didn't do anything to the exponents at all. So if we're adding exponents, what do? Nothing. This is a tier system. The way I remember it, so that I don't have to memorize a whole bunch of stuff, is remember the tier system. Exponents is multiplying over and over again. Multiplying is adding over and over again. Adding over and over, or adding, well, there's nothing beneath adding. That's as simple as you can get. So when I'm working with my exponents, I just go down a tier, and that's what I do to my exponents. If I have a power to a power, I'm obviously multiplying. If I'm multiplying, I'm obviously adding. If I'm adding, obviously I can do nothing. All right, that's it for this one. Let's go ahead and do our bug work. All right, this one is going to be section 7.3. Hashtags, gotta believe in a higher power. Let's see, 1 through 17 odd. Sorry I'm not talking right now. My throat's being a little mean to me at the moment. 41, 45, 51, 53. I know, it's so much, isn't it? Don't worry, these are all like super duper pathetically easy. You should be done with them in like 2 minutes. Okay, that'll be all. Honestly, if you work hard, you should have all of these done in about 5 minutes. They're all basic addition and multiplication. There's nothing super fancy or super difficult about them. Alright, good luck and have fun.